Welcome to this lecture. In the last lecture, we looked at the class diagram. We looked at the class relations. There are 4 types of relations that can exist among classes, and also we looked at how to identify the classes from a problem description, and also to identify relations and to represent them in a diagram. But we mentioned that even though it appears very simple to identify the classes just by reading a statement and also to identify the relationships, but lot of practice is needed. In the last lecture, towards the end, we had done some practice on identifying class relations. Today, let us start with some more practice. Let us I will display a simple statement. We need to identify the classes and also the relationship that exists between them, and if we are able to identify, we can represent them in a class diagram. Okay, let us get started. The first one is a square is a polygon. So, what are the classes here and what relationships exist between these two classes? This is rather straightforward. The two classes are square and polygon, and there exists a generalization specialization relationship. It is a Hijae relationship. You can see the Hijae phrase there, which quickly identifies the type of relationship between square and polygon. But the question is, which would be the base class and which is the derived class? Is square derived from polygon or polygon derived from square? So, here the polygon is the base class and square is a special type of polygon. So, the inheritance relationship between polygon and square, and polygon is the base class and square is the derived class. The next one is Shyam is a student. Please identify the class and relations. If you look at this statement, student is a class and Shyam is a object. It is not really a class, it is just an instance of a student. So, Shyam is an instance of the student class. Every student has a name. So, what are the classes here? Student is a class and name is a attribute of the student class. 100 paisa is 1 rupee. Here the two classes are rupee and paisa, and there is a composition relationship. 1 rupee is a composite class and it consists of 100 paisa. But then we need to be careful that this is not an aggregation relationship, it is actually a composition relation, because a rupee consists of 100 paisa, we cannot make it 99 paisa or 101 paisa. So, the paisa in 1 rupee is fixed, and therefore, this is a composition relation, and we all know how to represent the composition relationship. Please draw the diagram. Even though I am not drawing here, please look up the syntax and please draw the diagram. Rupee is 100 paisa. Students live in hostels. So, here the two classes are student and hostel. We need to use the singular form. The class name is not students, the class name is student and the other class is hostel, and there is a association relation between student and hostel. But then what about the multiplicity of the relation? A student lives in one hostel and a hostel can have many students. How do we represent that in a class diagram? Let me just draw this one. Student and hostel. There is an association relation and the student, this is the reading direction, student lives in hostel, but then we have to give the multiplicity, and for that we need to identify one object of one of the class is associated with how many object of the other class and vice versa. So, a student lives in one hostel. So, we can write here 1, but if we do not write 1, by default it is 1. So, to be safe we can write 1, but if we do not write, that is still okay, because by default it is 1. But if we read it the other way, a hostel, in a hostel many students live. So, this will be star. So, the correct class relations is association relation between student and hostel, and we should get this kind of relation. Now, let us look at the next one. Every student is a member of the library. So, here library aggregates all students, is the aggregation relationship, because every student is a member of the library, and we know that aggregation is a special type of association, and if you write this as an association relationship, still it is acceptable, but then we have to give the multiplicity, the association name, reading direction, etc. correctly. Next one, student can renew his borrowed books. Here there are 3 classes: student, book. Okay, there are 2 classes, student and book. Student can renew his borrowed books, and we can draw an association relationship. So, this implies the student can renew. So, there is association relationship between 2 classes, student and book. There are 2 classes here. Now, let us look at the next one. The department has many students. The 2 classes are department and student, but we can debate whether it is an aggregation or a composition relation. To resolve this, let us see that whether the department, when it is created, are the students fixed there, because the implication of the composition relation is that when the whole is created, the parts are also created, and when the whole is destroyed, the part is also destroyed. The parts cannot be added or deleted. But then to the department students come and go. Students may leave the department, graduate, or otherwise they may leave the department, new students join. So, the department and student is a aggregation relationship. Department is the composite class and student is the component, and department has many students, and that is aggregation relationship. Please draw the aggregation relationship between department and student. Now, let us look at few more exercises. Some more exercises, because as I said that we need some practice to identify the classes and their relations. The first one here, the country has a capital. The country has a country has a capital city. The two classes are country and capital city. And what is the type of relation? The giveaway here is the Hijae relation, and we know that Hijae implies aggregation or composition, and since the country has a fixed capital city, normally we can make it a composite relation. Country has a capital city, it is a composite relation, but then we may consider that even the capital city can change, and in that case, if that is allowed, then we can make it a aggregation relationship. Hijae is typically an aggregation relationship, even though it is just one instance. Aggregation is normally many components, but here there is only one, but because of the Hijae we can represent it as an aggregation relation. A dining philosopher uses a fork. So, the two classes are philosopher, the dining philosopher, and uses a fork. So, the dining philosopher is a derived class of the philosopher, if we think so. Otherwise, we can just write the philosopher is a class and uses a fork. So, there is a association relation between the two classes fork and philosopher, and the association relationship is uses. A file is an ordinary file or a directory file. So, the giveaway here is the Hijae relation. A file is the base class and ordinary file and directory file are the derived classes. So, there are three classes here: file, ordinary file and directory file. So, we can draw here file is the base class and ordinary file and the derived file, directory file, these are the two derived classes. Now, let us look at the next one. A file contains many records. Contain is the giveaway here. So, there is an aggregation relationship between file and record. File contains many records. Now, let us look at the next one. A class can have several attributes. Attribute is normally not a class, because we do not have methods or operations and private data, public data etcetera associated with attribute, just one value may be. So, this is a several attribute, it is not really a class attribute. So, there is class and attribute is a part of it. Relation can be association or generalization. So, this is again a generalization specialization relationship or inheritance relationship. Relation is the base class, association and generalization are the derived classes. Now, let us look at this. A polygon is composed of an ordered set of points. Here the giveaway is the composed of, and this phrase indicates that a polygon permanently contains set of points. We cannot just delete some point here, add some point here. When a polygon is created, the number of points in that is fixed, and therefore, a polygon is a composite class of many points. Now, let us look at the last one. A person uses a computer language on a project. There are three classes here: person, computer language and project. But then what about the relation between this? Person uses a computer language is an association, and again language is used in a project. So, that is again an association. The three classes are person, computer language and project, and the association relationship between the person and computer language and project. Now, let us just recapture what we discussed in the class diagrams. The class diagrams describe the static structure of the system, unlike the object diagrams which is dynamic, because as we said that the objects may created, deleted, links established, destroyed and so on. But a class is the static structure of a system, association, relation, aggregation etcetera, they are permanent between classes, and therefore, we say that it is a static structure of a system. The main constituents of the class relation, the different types of class relations are generalization, aggregation, association, dependency, composition, and we had seen the notations for that. An association typically appears as a Hijae clause in a statement, and then it can be represented by a simple line or an arrow. Aggregation relationship, a diamond with an arrow, a dotted line with this kind of arrowhead for a dependency. Generalization is an arrow with this kind of dependence, is a line having an arrow with this kind of symbol, and then implements. Again here it is similar to a generalization inheritance relation, but here it is a dotted arrow. The object diagram, just like a class diagram, they can either appear with the name of the object or some attributes of the object or the methods that are available, attributes. And here it is a rectangle with rounded edges. So far we have looked at the use case diagram, the class diagram, and the object diagram is simple, we did not spend too much time. Now, let us look at some behavioral view of a system, and we will look at the interaction diagram. the interaction diagrams, they can model the way the objects interact during the run of the system to realize some behavior. But then what can be a behavior of a system? The behavior is when we execute it, it does something for us. For example, issue book, return book. So, that is the behavior of the system. And if we think of it, the behavior is either execution of a use case or part of a use case. So, we model here using interaction diagram that when a use case executes, what are the objects that take part and what messages they interchange among each other. But the question here is that when we model a system, how many diagrams to draw, how many interaction diagrams? The answer is simple, we draw as many use cases are there, because each interaction diagram captures the behavior of a single use case, and therefore, the number of interaction diagram is typically equal to the number of use cases. But of course, if the use case is very complex, we might split into multiple interaction diagrams, but if we have designed well, then we might have decomposed the use cases, so that none of the use cases is very complex. So, therefore, the number of interaction diagram should be equal to the number of use cases identified. And we must remember, it is a very important statement here, that we need to develop one interaction diagram for every use case. We will see that the interaction diagram are either a sequence diagram or a collaboration diagram, and we need to draw one sequence diagram for each use case. The interaction diagrams, they capture how the objects interact during the run of the software to realize some behavior, for example, a use case execution. And here we need to identify what are the objects that are interacting during the execution of the use case, and what is the messages they are exchanging among each other, and the time ordering of the messages. And we will see that we will have ways to represent some control information, like whether there is a sequential flow from one object to another object, the control just flows from one object to another object. There is a branching, that is depending on some condition, the control flow occurs from one object to another object or some other object. Iteration, multiple times control passes from one object to other object and returns. Recursion, concurrency, and so on. But we must remember that for every use case, we need to develop one sequence diagram. Sequence diagram is one type of the interaction diagram. There are actually two types of diagrams, the sequence diagram and the collaboration diagram. If this is our use case model, then we need to develop one sequence diagram for each of these use cases. We can take any one use case and draw the sequence diagram for this. The sequence diagram will look something like this, that what are the objects that participate during execution of the use case, and what kind of messages they exchange, and the time ordering of those messages. So, here this diagram, at the top we mention the objects that interact, even though it looks like a class symbol, but then just look here, we have underlined here library member is the class name and member is the object when we underline that. This one is a instance of the book class, small book is an instance of the book class, and then here just see here in this we have not even mentioned what is the name of the object, and that is because it is an anonymous object, any book copy. And the diagram is typically read from top to the bottom. This we call as the timeline, and these arrows here capture the sequence in which the messages are exchanged between various objects of these classes as the interaction between them occurs during the execution of the specific use case. So, to start with, the user issues a borrow book request and he needs a specific type, that is book, that is given as the argument here, and then this is a self method here and checks whether the member is eligible to borrow book. He has not exhausted his limits, number of books that he can issue, etc. And just see here, there is a recursion here because the same one calling here, and then this small rectangle here is a indication that the object is active now, it is executing its code. And then it, depending on whether he can borrow the book, that we write here in the form of this control statement, that okay, if the condition is true, then invoke the borrow member. So, the book class, the specific book I mentioned here, that this is the book here, and then the book, for the book class the method borrow is activated and the member class waits here for the result to return, and that is how we not really stopped this rectangle here, it continues. And once it comes to the book, the control comes to the book, it gets active, and then it the book has many copies, and the specific copy that would be issued, any one of the copies, the member who is issuing it, it is registered there. So, that next time we query that who has taken the book copy, then we can find that the member has taken the specific member who was requesting has taken the book. So, this is the essence of a sequence diagram. Basically, we will identify what are the objects, and for execution of a use case, in what way they interact, which messages they exchange, and in what time ordering. We are at the end of this lecture, we will stop here and continue in the next lecture. Thank you.